Hi, welcome back to Lussac Chemistry. This is on Gay-Lussac's gas law. This will be our lesson B. In this lesson, we'll do two problems. Okay. So remember that Gay-Lussac is pressure-temperature relationship. So it's P1 over T1 equals P2 over T2. But it's more easily mathematically solvable, at least for people, if you write it like this: P1 T2 equals P2 T1. Okay, now, to solve this problem, there's a couple things we need to know. We would have to remember that temperature has to be in Kelvin. That's a must, okay? Your pressure could be in anything you want it to be, as long as both pressures are going to be the same. But temperature, don't use Celsius or Fahrenheit, use Kelvin. All right, so let's go ahead and set this problem up. So the pressure in the cylinder is at 300 kilopascals and 300 Kelvin. What is the new pressure if the temperature is raised to 500 Kelvin? Pretty interesting. All right, so what we're going to do is this. We're going to go ahead and we're going to figure this out. So first thing I want to do is I want to write down P1 T2 equals P2 T1. Then I want to put right here P1 T2 P2. Sorry, I didn't mean to do that. I love it when I make a mistake. P1 T1 P2 T2. I mean, it's so much fun when you do these videos. Sometimes you think, oh, I gotta get this done. This is so cool. But things, sometimes you gotta kind of just slow down. All right. So anyway, what's our first pressure? Our first pressure is 300 kilopascals. And we can use kilopascals. Our first temperature was 310 Kelvin. So, guess what? We don't have to do any conversion here. It's all good. Our second pressure is what we're looking for. And our second temperature is 500 Kelvin. All right, so we're looking for P2 right here. So if we want to find P2, that means we've got to move T1 under. So we're going to set this up. P2 equals P1 T2 divided by T1. And all we have to do now at this point is simply plug in our values. I mean, how easy can this get? So you go P2 equals 300 kPa times our second temperature, which is 500 Kelvin, divided by 310 Kelvin. Well, cancel out your common units. That's going to leave pressure left, the kilopascals, right? Okay, great. This is pretty snarly. So all you have to do is just use your calculator or a piece of paper, however you like to do your math. I remember the days without calculators. It took a lot longer to do these problems. So you got 300 times 500. And that gives us like 150,000 on top, divided by 310. And now remember, this is going to be kPa. So all we got to do is divide 150,000 by 310, the old calculator here, and that's going to give me 483.87 kPa. That was pretty easy. All right, let's look at another problem, okay, guys? So let's go ahead and erase these drawings. Okay, here's our new problem. A ball has a pressure of 125 pascals. Oh, we're using pascals this time. Okay. At 40 degrees Celsius. What is the new temperature if the ball pressure is increased to 1,005 pascals? Well, first thing I want to do is make sure I write down Gay-Lussac's law. Okay. It's always good to practice writing down the law. That way you don't forget it. So P1, let's see here. I'd like to make it a little bit nicer. P1 T2 equals P2 T1. All right, and remember that temperature has to be in Kelvin, right? That's what temperature has to be in. Is this in Kelvin? No, that's in Celsius. So we're going to do something different here. So to convert Celsius into Kelvin, it's pretty easy. We just go K equals C plus 273.15. I mean, how easy does that get? All right? So now, let's go up here and let's write down P1 T2 equals P2 T1. And again, let's do this P1, see if we can get this right. T1, P2, T2. This is so much fun. I could tell you could do this all day. Or maybe not, huh? So anyway, you have 125 pascals. Okay. Our first temperature was 40 degrees Celsius. And we're at 1,005 pascals this time. And we want to know what the new temperature is going to be. Well, before we can do anything, hold the fort. We've got to convert Celsius here into Kelvin. All right, so let's do that. All right, so let's see. We go K equals 40 plus 273.15. The old calculator here. 40 plus 273.15. That's going to give me 313 for Kelvin. So Kelvin is going to be 313.15 K. So we can actually scratch that and make that 313.15 K. All right, now we're ready. So we want to find T2. That means we got to move P1 underneath, right? Okay, so we're going to write this as T2 equals P2 T1 over P1. Not bad. So we're going to go T2 equals P2, which is 1,005, right? So 1,000, and 5 pascals. All right, it looks like there's a stray mark on my chalkboard there. We got it. All right, so we're going to multiply that by our first temperature, which was 313.15 K. Notice we don't say degrees in here because we don't use degree marks with Kelvin. Okay, and our first pressure was 125.0 PA. Well, we cancel our pascals. That's going to leave our temperature left over. So we just simply plug these numbers into the calculator, which is pretty simple to do. Or you can use paper, however you want to do it. Times 313.15. Sometimes people like to sing songs as they do this stuff. I'm not really sure why, although it does kind of help. So 314,715.75 divided by 125.0. And of course, this is in Kelvin. Boy, this is going to be pretty darn high, I think. So we divide that by 125.0. Wow, that's pretty significant. They were talking about like a temperature of a cool surface of a star or something like that. So you're looking at 2,517.73 Kelvin. All right. Well, that's it for this video. You guys be snarly, and we'll see you back here at Lussac Chemistry.